In this video, we will learn how to find the values of trigonometric functions at pi by 2 minus x. We will try to understand why sine of pi by 2 minus x is cos x, cos of pi by 2 minus x is sin x, and tan of pi by 2 minus x is cotx or cotangent of x. Let's get started. Let's consider a unit circle and let P be a point on this circle which creates an angle of x. Let Q be another point on the circle which creates an angle of pi by 2 minus x. Now we will extend P perpendicular to the x-axis and this is point M. Then we will extend Q perpendicular to the x-axis and this is point N. Now we have two triangles ONQ and OMP. So angle at N and angle at M are 90 degrees or pi by 2. Now let's draw those two triangles separately so that it's easier to analyze. So this is ONQ. So ONQ has pi by 2 minus x, 90 degrees or pi by 2. We don't know the value at angle at Q. Then the other triangle we want to understand is OMP. So O, M and P, right angled at M. So the angle here is x. We have to find the angle at P. So let's consider the triangle ONQ and get all the angles calculated. So in triangle OMP, we have pi by 2 minus x plus pi by 2, then plus angle at OQN. This is equal to pi or 180 degrees. So the angle at OQN would be pi by 2 plus pi by 2 is pi minus x plus OQN is equal to pi. So the pi gets cancelled. Angle at OQN is x. So now we know that OQN is x. Now similar way, let's find the angle at OPM in the second triangle. So in that case, we will have x plus pi by 2 plus angle at OPM is equal to pi or 180 degrees. So angle at OPM is equal to pi by 2 minus x. So now we know that angle at P here is pi by 2 minus x. Now if we notice, we see that there are common angles, which is pi by 2 is available in both the triangles, 90 degrees is available in both the triangles, and the value of OQ is equal to OP because it's the radius of the circle, and in this case it's the hypotenuse. So in this case, triangle ONQ and triangle OMP are congruent because of the RHS criteria. So I have made a video, I think it is video number 2 in this playlist. So please understand what are congruent triangles. So there is a criteria called RHS criteria, which is right angled, hypotenuse and side. So these two triangles meet that. So triangle ONQ and triangle OMP are congruent to each other. Now we know that these two triangles ONQ and OMP are congruent to each other. So ON is equal to PM and QN is equal to OM. So let's go back to the circle now. If the length of ON is equal to PM, if these two are equal, that means in the circle, the x-axis here in this triangle is equal to the y-axis of the other triangle. So Q becomes B comma A. That is because the opposite sides, the side which is the x coordinate is equal to the side which is the y coordinate of other triangle and vice versa. So now if Q is B comma A, let us apply this to sine of pi by 2 minus x. So sine of pi by 2 minus x. So sine was the y coordinate. Now it has changed to x coordinate. So this will be cos of x. Similarly, cos of pi by 2 minus x, which was the x coordinate, has changed to the y coordinate. So pi by 2 minus x, when that is the angle, sine changes to cos and cos changes to sine. Now let's apply this to tan. Tan of pi by 2 minus x is sine of pi by 2 minus x divided by cos of pi by 2 minus x. So sine of pi by 2 minus x is cos x because the coordinates interchange, and cos of pi by 2 minus x is sin x. So we will have cotangent of x or cotx. So tan of pi by 2 minus x is cotx. So this is how we can find the trigonometric functions at the angle pi by 2 minus x. Please add this to your tables so that it is easier for you to remember and use it in solving numericals. Thank you for watching. I'll see you in the next video.